Okay, so we are going to continue with our graphing and describing of quadratic functions. And we are going to actually be describing everything at this point that we have learned, including everything that we did in linear. So far we've already done domain and range and things like that. So now we're going to be putting it kind of all together. So we're also going to be taking it up to the next level by using Desmos graphing calculator, the online calculator, to graph our quadratics. So we can actually see all the points, and I'm going to show you how to do that as well. Okay, so let's get to it. So first example. Okay, I've gone ahead and given you the equation. I've given you the graph just in case you're having kind of a hard time putting it into Desmos, but I'm going to show you how to type this into Desmos. So y equals x squared minus 3x minus 4. So we're going to type this in. It's got a wonderful calculator or a wonderful keypad that's in here. So y equals, x is over here on the left, x squared, and that was minus 3x minus 4. Okay, so minus is over here, minus 3x minus 4. Okay, so you hit the little down arrow over here on the left, and it will hide your keypad. We don't need that right now. Now, with your iPad, you can actually zoom in by pinching the screen or pushing it out. You can zoom in and zoom out. You can also click anywhere on this graph, and it will give you a point value. You can drag it, right? And it will do all of this. You can also go up to this little settings wheel on the top left, and it will give you some options. You can change the color of the graph, which we're not really worried about right now, but this option right here will actually give you a table of values. And the neat thing is, it's a table of values that you can substitute other numbers in. You can substitute any numbers in that you want to see what the actual points are. Okay, so right now, it's got our basics from -2 to 2, and it's going to graph them. And let's see, so -2, 6 would be here, -1, 0, 0, -4. It's got +1, 6, 1, -6 rather, and 2, -6. Okay, so our vertex is not in that table. But if I want it, again, I can drag my pointer over to it and place a point, and it will tell me what my vertex is, because remember, the vertex has to be in the very, very middle of my graph. So 1.5, -6.25 is my vertex. So I'm going to go ahead and write that down on our paper. All right, so the vertex was 1.5, -6.25. And again, you could also take the graph that I've given you and at least make an estimate of where it is. But this is why we're going to be using the Desmos graphing calculator. Okay, so X-intercepts and Y-intercept. All right, so again, go back to your Desmos. Okay, so my X-intercepts, again, are on the X-axis, so that's here and here. On the X-axis, all you have to do is just tap on the screen on the axis and it will come up. So -1, 0, and 4, 0. Okay, and then again, your Y-intercept is where you are on the Y-axis. So again, go back to Desmos. On the Y-axis, right there. Now again, if you wanted it to come up on here and it wasn't showing up, okay, we know, so you just click down here right up underneath the table. After that table you do. If I want the X-intercept, then I have to make Y equal 0, and you just have to tap it in. If I want the Y-intercept, I have to make X equal 0, and it will come up. If I want the Y-intercept, then I have to make, or I can't even do that. If I want the X-intercept, I have to make the Y equal 0. Now, you cannot do that. You cannot substitute in for Y first. So in order to get your X-intercepts, you're going to have to drag on your graph. But for your Y-intercept, you can always substitute in 0 for X. And again, for the vertex as well, if it's not a whole number, you can just tap on the middle of your graph. So Desmos is very helpful for a lot of things, being able to pick out a lot of information on these graphs. So it's 0, -4 was the y-intercept. Okay, so max or min is something new. It basically is asking whether your vertex, right, the middle of your curve, is the highest or lowest point of the graph. And in this case, it is the lowest point of the graph, so it is a minimum. You don't have to state what the minimum is, you just have to state if it's a max or min. All right, your axis of symmetry, we've already done this before. It's always x equals whatever the x value of your vertex is, so 1.5, and I can prove that if you need to use the formula. Remember, the formula is -b divided by 2a, so that's going to be +3 because we changed the sign, divided by 2 times 1. Well, 3 divided by 2 is 1.5. Okay, so we've already done domain, so this should not come as any surprise. The domain is from negative to positive infinity. It goes all the way across the graph. There's a reason why when we draw them by hand, we put the arrows on them. If I were to go back to my Desmos, I could keep scrolling out, and this graph is going to keep going and going and going. And notice it is going both to the left and to the right. And by the way, if you do that and you want to undo it, you hit the home key that's there. Okay, so the domain is from negative infinity to positive infinity. The range is based on your vertex. We've talked about that before, and which way the graph is going from there. So the bottom, since we said this was a minimum, the bottom of my graph is that negative 6.25. And it's going up from there. So it goes from negative 6.25 to positive infinity. Okay, so increasing and decreasing we did with linear. And linear was either always increasing or always decreasing. So here we finally get to have a function that's doing one of each thing. Okay, now if you remember back from when we were doing this with linear, it's based on the x values, right? You started at negative infinity on the left, you finish at positive infinity on the right, and you stop and change direction wherever the graph stops and changes direction. In this case, it's at the vertex, which is 1.5. Okay, we talked a little bit about how to tell which way it's going. Well, since we're starting on the left, again, if you put your little roller coaster car with your guy in it or your girl in it that's, screaming and yelling and raising their arms and riding the roller coaster, the first thing that this graph is doing is going down. So it is decreasing from negative infinity, and it stops decreasing when it gets to this x value. Remember, always the x values for this. So it is decreasing from negative infinity until it gets to 1.5, and then it turns back around starting at 1.5 and going to positive infinity, and then now it's going up. So think about like when you graph it and we start on the left and draw a curve through the points, it's going down first and then up, or if it's upside down, then it's going up first and then down like a hill. So this one's like that first big drop on the roller coaster, down then up. Okay, and we'll do a negative one just so you can see the difference. But this is all the different things that we've learned how to do to describe a function. And now you can do it on quadratics. All right, so let's try another one. Okay, so let me get this typed into Desmos, negative 2x squared. Now, here's the interesting part on Desmos. I don't have to delete this function, right? I can make it disappear. And then I just go up underneath there and I can type in another function. See, these are numbered, 1, 2, 3. I don't think there's an actual limit on how many functions that you can put on there. But again, we don't want it to be cluttered up because if I'm graphing another one and I see both, I may mess up my points. So y equals, okay, negative 2x squared plus 2x plus 4. So plus 2x plus 4. Okay, so hide the keyboard because we don't need it right now. Okay, so I've got some points that are already showing up. I can find my vertex on this one right in the middle of my graph. And then I have my y-intercept there and my two x-intercepts there. That's kind of nice. That shows up very nicely for me. So I actually have all of those pieces already filled in. And as you can see, when we're talking about as far as it being upside down, this looks like the first big hill on a roller coaster where first you're going up, increasing, and then you're coming down, decreasing. So let's go ahead and fill in all the pieces that we can pick out from this. Okay, so the x-intercepts were at, should be -1 and +2. Okay, and I can see that on the graph that's here as well, -1 and +2. My y-intercept is at +4. Okay, make sure you're writing those as ordered pairs. My vertex was, let's take a look at that again, 0.5 and 4.5. Okay, so, and I can write that as a fraction too, it doesn't matter. But again, I can prove it because if I use my formula, my -b divided by 2a to get my x, I get -2 divided by 2 times -2. Well, -2 divided by -4 is a half, which is 0.5. Okay, so again, take a look at the graph. That vertex is the highest point on my graph, right? Everything goes down from there, so this is a maximum. My axis of symmetry is either x equals 0.5 or x equals a half, right? It has to be the x value. The domain, again, has not changed and won't until we start talking about real world functions. So it's -infinity to +infinity. All right, so let's take a look at the range. This time my graph is going down. So we already said this was a maximum. So remember, we put our lowest number first. So it's -infinity to that 4.5, that y value of that vertex. That vertex gives us so much information. Okay, increasing and decreasing. Again, this is -infinity on the left, +infinity on the right. And starting on the left-hand side, because that's what we always do as far as when we're reading graphs, we're starting on the left-hand side. And if you were watching somebody go on this roller coaster, they would be increasing first from -infinity to the x value of that vertex, because it's always by the x's. So that's to 0.5. And then I'm going to start at 0.5 because I have to start and stop at the same place. And I'm going to decrease until I get to +infinity. I know that sounds really, really weird, but you're going from left to right across the graph, not up and down. Okay, so that is all of my pieces. Now we do have one more thing that we have to be able to do. And again, we're going to use the desmos calculator for it. And it's going to take a little bit more time because I'm not going to give you a function. I'm going to give you a set of points. And you're going to have to do, oh, okay. I thought we were just going to do it from the set of points. And we're going to have to be able to identify all of these pieces from just a set of points. So we're just going to ignore the equation for right now, and I'll show you how this works. All right, so back to desmos. And again, I don't want, see how it'd be really confusing if I had both functions there. I don't want the functions there. But I do need a table. Okay, so I'm going to go up here again to that edit. And nope, that's not it. Where are we at? Oh, here, the little plus on the left-hand side. Add an item. I need an add a table so that I can graph all my points because I need to see what the curve looks like. Okay, so -520 and -49 are my first 2 points. So you just type in from your keyboard -520 and just click underneath of that, -49, and click under that and just keep adding your points. So -30, -2, -7. All right, so -3, 0, -2, -7. -1, -12, and 0, -15. Okay, so -1, -12, and 0, 15. All right, and then I know my next number is going to be 1 what? 1, -16, and then 2, -15. So 1, -16, and 2, -15. Okay, and then the next one should be, because remember, these are symmetric, and that's supposed to be a -15 on the 0. So the next one should be 3, -12, and it is. Okay, so 3, -12, and then 4, -7, and then 5, 0, and then 6, 9. Is that how far that went? And then 7, 20. Okay. And then 7, 20. All right, so close your keyboard out. So let's take a look if we can see all the points on my graph. Oh, okay. That really does look like one of the curves that we have been graphing. And even though it doesn't have the lines through it, I can still actually pick out the information that I want. Okay, because specifically, I have a vertex down here at the bottom, the middle of my graph. Okay, I have a y-intercept right next to it. I have my two x-intercepts here. And again, if I have that vertex, then I have my range. I have my intervals of increase and decrease because it uses those values, right? I have my axis of symmetry. I have everything I need. So even if I don't have a function, if all I have is a group of points, I can still actually pick out this information. Okay, so we know that's going to be the vertex. So 1, -16. We'll go ahead and fill that one in. All right, so 1, -16. So that means the axis of symmetry is x equals 1, and the vertex is 1, -16. Now, if you're really good at following patterns, you can also do this just from the table, because take a look at where the symmetry is. You have a matching set of -15s, -12s, the y values. Remember, they're symmetric. So if you go to the middle of all that symmetry, the vertex is 1, -16. That's the point. Okay, and x-intercepts are where y equals 0. So right there. So that's going to be -3 and 0 and 5 and 0. Okay, so the y-intercept is where x is 0. So that's 0, -15. Okay, now the increasing and decreasing might be a little bit harder without actually seeing the points graphed. The only suggestion I would make for that, if you're trying to do it just from the table, is take a look at the y values. Okay, so this is the very bottom. This is the vertex of my graph. Take a look at your y values. Are they going up or down from there? Right, they're going up from there in both directions, which means the graph has to look like this, because your y values are going up from your vertex. So your decreasing interval, which would be the left side at this point, will be from -infinity to the middle of your function, which is 1. And again, we can prove that by looking at the desmos and looking at the graph, right? If this is my vertex, then this would be the side that would be going down. So remember, this is -infinity off to the left. So from -infinity to 1, the graph is going down, and then it turns around and goes back up. So again, you can graph this in Desmos. There's nothing wrong with that. But if you're good at looking at patterns, you might be able to pull these from just the table. Okay, so that means my increasing has to be from 1 to +infinity. Okay, that's it. After this, we are going to be talking about factoring, which is going to help us if we don't have access to a calculator to graph it. It will actually help us solve for our x-intercepts. So we're going to do a review of factoring, and I'm also going to show you one more way on how to solve quadratics in standard form.